All right, so the last part that we need to figure out before we can start putting in navmesh links is to know exactly which edge it's going to start using. So we need to get this edge between this red surface and this white surface. And then we also need to get it between this red surface and white surface, and this red surface and white surface, and this red and this green and white. So we need to separate those all. So let's go into the next script. This one is actually separating them all out. You can see we have the black line here, but not on this one, and not on this one. And it doesn't look like there's one here, but there actually is. It's just harder to see in the corner. All right. So this is the same outward script. It's Navmesh Builder 3 now that I'm onto. And let's take a look at what the differences are. So again, we have our triangle class. We have a normal being called out in it. We have a surface. We have a transform points script, which this is new. So the transform points, we used to take care of the transform points at the spot where we were drawing them. Now what I'm going to do is transform them very early on. And I figured just create a script to do it so I don't have to go through each one and do it individually. Okay, so that's the transform points. Then there's also this SharesBorder script. This one is used to determine whether or not it shares a border. And the code of it is pretty straightforward. We need to know, so over here we have, first off, is it the same surface? If this triangle, so this is a function between the triangle we're in and another triangle that it's comparing to. If both have the same surface, we return a false right away. And the other two values in this tuple don't matter. So we return a false, indicating that no, this doesn't share a border. And specifically, it doesn't share a surface border, a border between surfaces. It doesn't share a border between surfaces. Okay, so next thing, if we get past this, that means there are two different surfaces between these triangles. The next thing we need to do is actually figure out, do they line up? Okay, so over here we're checking to see all of these positions. I'm just doing a really simple one here where I'm just putting in a list. Big deal, it's going to have 2 items in the array. I could just put a 2-item array here and that would work as well. Where I effectively just say this.position. If the position 0 equals T1 position 0, then we know it's the same. And we add that position to our array. And then we continue down this list, so we're comparing the 0 position of ours to the second triangle, to its next position, etc., etc. So we continue comparing that to each of the other triangles' positions. Then we do that for the second position of our triangle and compare it to each position of the triangles. At the end, if the shared count equals 2, that means it found 2 edges that are matching. That's all it should find. If you happen to have a triangle set up in your system somehow where 2 of the vertices got pushed together, then I suppose you could have one where it's combined, but you're not really going to see that anyway. Okay, so inside of here, we end up having, we're returning whether or not these 2 positions are against each other. Okay, so if we found 2 of these vertices that lined up between the 2 different triangles, then we effectively pass back a true and pass back what the triangles were. The shared is a list of vector 3s, so we pass back 0 and 1, which should match the count that's here. Otherwise, if that's not the case, then we return false, and it doesn't matter what we return here. All right, so now we go on to the gizmos. We don't care about that color list. We don't have a color list anymore. We do have the triangles. I can get rid of this line. We do have the triangles and the vertices. So I create a new list of triangle classes. It's empty at the moment, but we're going to go through, and for every triangle, again, groups of 3, we're going to create a new set of positions, and we're going to set the normal here. Now this is broken. We're ending up getting this position, and then we're getting the normal, and that is broken. So in this one, we will fix it again later. I went over in the previous video how that was broken and the fact that we're still living on the wrong normal. So we'll get it fixed in the next script. All right, so we set the positions, we set the normal. Then we go over to here and we say, all right, do the comparison on the get surface to get the surface for that normal. Again, same script as last time. Then we transform the points. So this is where we're transforming the points. We transform it right away. That way, everything else that's using this is using real-world spaces already, and it doesn't need to apply it anywhere else. That's going to make the math a little bit easier, so we don't need to reapply everything after it. We're applying it to where it really shows up in our world. And then, of course, we add the triangle. All right, so now we're going to go on, and this is still inside the onDraw gizmos selected. We're going to go through this, and it's much smaller this time too, because we have less that we're doing. We're effectively going to go through each one of the triangles. We're comparing them side by side. I believe we did the same thing last time. And we are doing, for every one of these first set of triangles, we start with the first, for the first one, we start at 0, move on to the count -1, so we never actually get to the end one in this one. And then this one, this one's actually got a mistake in it that should be starts with I1. Okay, so the second triangle starts with I1 plus 1. So we're starting one index ahead, and it goes on to the maximum. So this one can get the last one. This accidentally did have an overlap, which would have created some confusion, but the fact that they shared a surface would have kicked it out of the drawing anyway. So we get our second triangle, and we've got our first triangle. Try 1 and try 2. And then we're going to see, first off, do the surfaces match? If they do, then just skip it. Then we're going to call SharesBorder, because why process everything? But also, that means that our SharesBorder function, this line that's actually checking to see if the surfaces compare, isn't needed. It's already checked before it even gets into this function. All right, so continuing on with the code, we're over here. Let's see, we're checking to see if the surfaces are the same and skipping that if they are, because we don't need to check to see if the borders are, if there's a border between the same sides. Then we're going to check out, we're going to run the rest of that function. We're going to find out if they share a border. If item 1, because it returns item 1, item 2, and item 3. Item 1 is the Boolean. If this is false, so not true, it will continue. It'll skip it, and we will just, or if not false, then it will continue and skip the rest of the line. The last line is where it's just going to draw that line, and that's it. All right, so that effectively gives us our border edges, these black lines that wrap around. So now we know the exact edges of every single point where it crosses from one surface to the next.